Okay. Hello, guys. Hello. Anybody there? I can see Deborah. Is Deborah in? Is uh is Victor in? Are we in class really? Hello. Hello, sir. There's a lot of disturbance in the background. Okay. Let's see what we can do. So, welcome to our lesson today. I'm Victor Momanyi. We are going to cover the OSI model in computer networks. Uh, so to this far, I think we have covered a lot of content that will enable us to understand this part well. And I'm going to take the shortest time possible for us to cover what we are supposed to cover in a systematic way, and we are able to understand well. So, in our introduction part of this, what is OSI model? OSI, it means Open System Interconnection. This is a mechanism, this is a standard that was developed by the International Organization of Standards. ISO, I think that one is very common, and a number of people, or a number of you are supposed to rather to be able to relate well with that in the year 1984. So this one describes how software communication, or software application, communicate to other softwares. That is, one software application in one computer is able to change information or to exchange information with the other device or a computer or a host in a network. The movement of this communication is through a physical medium to another software application in a given computer on the network. So the OSI, remember, yes, as a mechanism of making these devices to communicate on the internet. Devices on the internet include your phones. I know a number of you are connecting to this session through smartphones, which are able to do, or rather to function well as our desktop computers or laptops that we are using to hold this session. Online learning is common these days. A number of your colleagues have complained and they are not able to connect to this session because they are in places where they have poor networks. But that one is understandable. It's technology. But then the next time, I will request that you position yourselves in places where you can be able to have a good connection for us to continue learning. Because at the end of the day, we need to deliver the fruits of this learning. So, what are the seven layers in this model, which is called OSI model? And the seven layers which enable this communication to take place between computers, between laptops, between mobile phones. There, as you are seeing on our slide, we start from the very end, the bottom where we are physical. We have the data link layer, network layer, transport, session, presentation, and application. Remember, the first three are responsible for the network. The responsibility of the first three is the network part of the layer, or that layer, OSI layer of communication. And then the last four, or the upper four, It's the responsibility of the host to make sure that the functionalities on those levels are a success. So just to look at the details of those layers in this slide 4, we have some brief definitions, or rather explanations on what each and every application does in this process of communication from one computer to another. We have the physical layer, which provides a physical medium through which bits are transmitted. So remember, computers have a language of transmitting and understanding what they are communicating. If I may ask, maybe what is this language that computers speak, and they are able to understand each other in terms of exchanging data? Anybody to try? Kindly, anybody? Yes, sir. It is in terms of bits. That is ones and zeros. Okay. That's a good trial. Yes, it's in terms of bits and in terms of bits, which is zeros and ones, and they are able to understand each other when they are communicating. So remember, you're going to look at the data link layers in this particular lesson. If time allows, we can go further and look at the network and transport. But our lesson is basically based on physical and data link layers. And remember, our objectives for our lesson today we should be able, rather, one should be able to understand what the OSI model is, the Open System Interconnection, what it is, the layers in that particular model, and at least the functionalities or what the layers are able to do in order to make it a successful communication between one computer and the other. So just to look at the physical layer, what it does. Just a moment, I need to confirm something here. Don't know, you are not connected to your side. You are able to see that side. Are you able to see what is on my screen on your side? Yes, sir, we are able to see that. Okay, that's better. Then let's continue. So the physical layer is the lowest layer of the OSI model. Then don't know. I have an issue with the. Okay, I think. It's okay. Let's continue. I have some itches on my side, but let's try to continue moving. So the physical layer enables line configuration. What is line configuration? This is a way in which two or more devices can be connected physically from using from using a medium, which is a network cable or the Wi-Fi that a number of you are using to connect to this session. So transmission defines the transmission mode, whether it's simplex, half duplex, or full duplex. Remember, these are means in which computers are able to communicate in a given medium. In simplex, only one device is able to transmit as the other one listens. Half duplex, one transmits first, then the other one will transmit once the other one is done. Then full duplex, both are able to transmit at the same time. So topology defines how the configuration and the outline of the devices is in a given network. Remember topologies from our previous discussions, previous units. We have covered the topologies that are in computer networks and are used in particular or different offices around. Remember, we have talked about ring, the bus topology, and others that you are able to identify. So signals can be determined by this layer. The type of signal used for transmitting the information can be determined by the physical layer, but at many times the signal is in terms of ones and zeros, as we have always understood that that is the major language that computers are able to use to communicate and exchange information. Remember, communication can be end-to-end and only can be confirmed by each and every host on the network using a particular mechanism defined by given protocols on how communication should be able to be delivered. In data link layer, we have two sub-layers. That's the logical link control layer, responsible for transferring the packets to the network layer of the receiver machine. Then we have the media access layer, which is a link between the logical link control layer and the network's physical layer. Then framing, as part of the work of the data link layer, is to frame. What is framing? Framing is just dividing the messaging into smaller transmittable sizes, which are called packets. So the packets are then turned to frames by adding headers and trailers to that packet. The header is added to the frame and it contains a hardware destination and the source address. Though the hardware is the physical part of that device or computer that is used or is meant to uniquely identify that particular machine on the network. So these two additions are made to identify which or where is this packet coming from and where it's going to. That's the destination address of those computers. That one will help much more in terms of controlling and able to identify the source and the destination of that message. And that's why we have now this wider in our current slide, the wider outline on how that happens. The physical addressing, how the addressing is done to those particular packets, how encapsulation is done to those packets and are able to reach the right computers. Remember, we have a number of computers connected to internet, so there must be something that is identifying that unique computer where this message is meant to be delivered. Flow control, the data link layer has a technique through which it has constant data rate that is maintained to transfer data from one machine to another in both sides of the network. Error control, we have the cyclic redundancy check, which is placed at the start. Sorry for that. It's placed to the data link layer's trailer, which is added to the message frame before it is sent to the physical layer. So remember, each and every time there is a transmission, there must be a check whether the whole information was was transmitted? Was it successfully transmitted to the destination? Did the whole message get delivered to where it was supposed to be delivered? So error control and error check has to be done by this mechanism called cyclic redundancy check. You have the access control when two or more devices are connected to the same network or on the same medium or a channel. Then the data link layer protocols are used to determine which device has control over the link at a given time. Now that one brings in the concept of a simplex, a duplex, and a full transmission over the medium. There must be a check on whether the link is busy and is being used by another device before the transmission or a retransmission takes place. Then this slide defines the outline or the outlook, the general view on how the data link layer is. So you can see the data link layer holds that header, which has T2 is a trailer, H2 is a header. And remember what we said about what these two parts of that frame are made up of. We talked of the source address and the destination address, where that packet is supposed to be delivered to. Then the physical layer receives and sends in terms of ones and zeros, as we had talked about that. So we can logically look at that using that diagram. In summary, we have talked about the open system interconnection model, which means that there is a way computers that are on a network are able to communicate and exchange information. And that is the model that describes that communication. Remember, it was developed by the International Standards Organization in the year 1984. It has 7 layers. We have talked about physical and data link. We have 4 others, which we are supposed to look at and understand the functionality of each and every of this layer, which is network transport session, application, and presentation. The first lower 3 are responsible for network, and the 4 layers up or above the 3, they are responsible for the host or the computer itself or the device that you are using. Then there is a related current model for computer communication, which is TCP/IP, meaning transmission control internet protocol. And maybe, if I may ask, is there any question up to that point, please? No question, sir. Well understood. Okay, then our assignment will be the last bullet on this summary slide. Kindly go and look at the TCP/IP model and get to understand what it does, and able to relate it with the OSI model. Also remember to look at the remaining 4 network layers before our next session, and then we'll be able to look at the two and compare and even discuss the functionalities, if they are related or if there is any difference on those layers, and be able to understand what may probably led to the development of the TCP/IP. Why is it that the OSI is running to be obsolete soon and it may not be used? So I want to thank you for attending this session. Encourage your colleagues always to be ready and be able to join such like sessions as we continue to make the learning as conducive as possible. Online learning is here with us. We cannot skip that. So make efforts to always make time to attend the session. I want to wish you well. And as you're going to start your exams, God bless you. See you in another session. Bye.